For y equals f of x, the function f of x, the domain of the function is the set of input values, usually we call those x, for which the function produces a valid output, meaning we want a real number. So in order to find the domain of a function, we've got to think in advance about any x value that might make the function undefined. Now, since we cannot divide by 0, we've got to exclude any x values that make a denominator 0. And if we have a square root, then we can't find the square root of a negative number. We must exclude any x values that make inside the square root the radicand a negative number. So let's start with an example. Here we have example 1, f of x equals the fraction x squared in the numerator divided by x minus 4 in the denominator. We want to find the domain for the function f of x equals x squared all divided by the quantity x minus 4. So the only thing that would make this denominator 0 would be if x equals 4, that's going to be a problem. So we have to exclude x equals 4. But every other real number, 4.1, 4.001, 3.999, 0, all the negative, every other real number is okay. It doesn't produce a divide by 0 problem. So if I think about this on the number line, I can't have the number 4, but I can have any other real number. So it doesn't include 4, but it can include all the numbers less than 4. It doesn't include 4, but it can include all the numbers greater than 4. So this domain has every real number except the number 4. So if I'm going to write that domain in interval notation, I'd write the domain is negative infinity up to the number 4. Then I've got to use a union symbol, meaning don't include 4. This parentheses means do not include the end value, and 4 up to positive infinity. So problem 2, we want to find the domain for g of x equals x plus 4 in the numerator and 2x minus 9 in the denominator. Very similar to the problem we just did. We can't have a 0 in the denominator, so 2x minus 9 equals 0 will result in 2x equals 9, x equals 9 halves. I don't typically change things to decimals unless I am asked to do so, so I'm going to leave that as 9 halves. Now remember, I can't have any of these. I'm not allowed to have a 0 in the denominator. So if I'm going to graph that, I can have any real number x except for 9 halves. So the domain in this case will be negative infinity up to 9 halves. Don't write mixed numbers. Don't write 4.5. And I don't include 9 halves, and then 9 halves up to positive infinity. So when you're doing a domain problem, you want to ask yourself, what values of x may I input into the function that will give a real number output? Are there any values I have to exclude because they'll make the function undefined or not a real number? So in this case, because it's h of x equals x divided by the quantity x squared minus 9, I've got to worry about a divide by 0 problem. So x squared minus 9 equals 0. Well, remember, this is x plus 3 multiplied by x minus 3 if I factor the x squared minus 9. And by the 0 factor property, I know that either x equals minus 3 or x equals positive 3 will make this 0. So I can't have any of these. So the domain in this case, and if you need to, you should draw yourself the number line, but the domain is negative infinity up to negative 3. I'm not allowed to include negative 3. Negative 3 to positive 3. I can't include positive 3. And then positive 3 up to positive infinity. In other words, every real value of x except 3 and negative 3. So in example 4, n of x equals the square root of the quantity x minus 5, I still have to ask the same questions. What values of x am I allowed to input into n of x that will make sure the function gives an output of a real number? Well, I can have 0 or anything above 0. So inside the square root symbol, I have 5 minus x, and that's got to be greater than or equal to 0. So if I add x to both sides, 5 is greater than or equal to x. And I know this is a little silly, but this open mouth, so what, the alligator eats the larger number, so the largest x is allowed to be is 5, and then it has to go down, doesn't it? It's pointing down to x. So this, if I was going to write it out, would be negative infinity up to 5. I'm allowed to include the number 5, but I can't include infinity because that's not a number, it's an idea. So there's my domain. Now, in the past, I've had people say, what about 5? That makes it 0. Well, guess what? The square root of 0 is 0. That's valid. So let's test this a little bit. What if I try to put in 5.5? So that's just above what the domain is allowed to be. So that would give me the square root of 5.5, subtract the number 5, and that is the square root of negative 0.5. Well, that is not a real number. Not real. So it's not defined in the real numbers, and I can't do it. Well, what if I try one that is allowed? Let's say negative 2. So n and negative 2. This one was not in the domain, so it didn't work. I expect this to work because it is in the domain. The square root of 5 subtract negative 2. And that's the square root of 7. And while it's not a beautiful real number, it is a real number. So that one is a real number and it's okay. So the domain I've come up with is correct. Now in this last example, I've still got to ask the same question. What values of, in this case it's going to be t, not x, can I input into my function s of t to give an output of a real number? So the problem is going to only come from the square root and also the fact that the square root is in the denominator. So unlike in problem 4 where I can have a 0 under the square root, now because the square root's in the denominator, I'm not allowed to have a 0 in the denominator. So now I need the argument, or what's inside the square root symbol, to be strictly greater than 0. Now I'm not allowed to include 0 because it's also in the denominator. So that means 5 is greater than t, and 5 then is the largest number and t is all the numbers that are smaller. So that means the domain is going to be negative infinity up to 5, but this time it cannot include 5, otherwise it'll make the denominator 0. So that's how you do domain. Ask yourself the question, what values of the input, usually x, sometimes t, may I input into the function to give a real number output that is defined?